Hi everybody, how you guys doing? It is April 13th and we are about to go over chapter 9, which deals with basically time value of money. The chapter is called Time Value Analysis, but we're going to get into future value, present value, what if it's a single amount, what if it's a annuity, something that kind of is an annual or repeating event. So I'm going to load up my working papers here, and hopefully you can see it. I will be uploading these working papers once we're done so that you could have them handy for when you take your next test. So in case you didn't get the email regarding the plan for the rest of the way, we're doing chapter 9 today, as I already mentioned. Next week, we're going to be doing chapter 14, which deals with capital investment decisions, the basics of capital budgeting. And then we're going to do chapter 17 the week after, and that's going to be on financial condition analysis. I think that's probably the easiest chapter out of them all, personally. So I think this is pretty easy. I think 17 is pretty easy. Next week's stuff, I don't know. It depends on you if you think it's easy or not. But I think 9 and 17 are the easiest chapters in the course. That's just my own personal opinion. But you may feel differently about it as we do it. So, and then we're going to be taking one final test, which I will upload after we do that chapter 17 class. And you basically will have a week to get that thing done. Okay? I think originally I said I was going to post it a week later, but I'm going to post it right away so that you can get it over with and done while the stuff is, pretty current in your mind. Okay? And there's no test 5, so what I did was I combined my test 4 and test 5 into one test, just because it just seemed like the right thing to do based on the situation that we got going on. So most likely what will happen in this last test, normally I have you do 4 questions out of whatever I give you. I'm going to have you do 5 questions out of whatever I give you. So we'll add another question to it, and hopefully I'll probably have a question on that, or that will, I don't know, I'm debating this or not, but I think I'm going to have it so that you have to do at least one question from chapter 9, at least one question from 14, at least one question from 17, and then the remaining ones you will have an option. I kind of did that with another test that we took, if you remember, like, hey, you got to do these, and then you can pick from the rest. Probably do something along those lines, just so every chapter is accounted for. Because on the last test, some of you did a smart job of looking through which ones were the easy ones, and there was probably a question or two that you probably didn't answer because you didn't have to, which I was kind of like, oh, I should have set it up differently, but oh well, live and learn. And you guys got to benefit that. So far, every test that I've graded that's been submitted to me has been an A. So 1, 2, 3, 4, 5, 6, 7. I've graded 9 tests so far, and every one of them has been an A so far. So hopefully the trend will continue. I should be getting everybody's tests that have not given them to me, should be getting them by tonight. If you do end up handing them after the due date, there is going to be a point deduction for lateness, 10 points. So just be aware of that. All right, and the same thing will happen for the next test. Your project, that'll be due the last week. So I think the last class meeting is May 4th. So that's when that should be done. All right, so literally 2 weeks from today, you should, 2 weeks from today, aim for having your project completed. All right, so let's get started here. In your Blackboard, I have uploaded some present value, future value tables. If you could pause me right now, this way you can go open those tables and then maybe either half screen or print them. And then this way you can have something to look at while I'm going through this material. Okay. I'll wait a few seconds for you guys to pause me. Okay, so if you didn't pause me, or if you did pause me, here we are, we're back, and I just want to let you know that if you didn't have the capability of printing the sheets, over to the right I have put a little glimpse of the sheets that are going to be important for us to do what we need to do today. So I kind of, just took a little snippet of the columns that we will be using. Okay? So I've got a little glimpse of a future value table of a single amount. I also have a glimpse of a future value annuity table. I got a present value table, just a little piece of it, and then another example of a little piece of the present value annuity table. And then I also did another example from the present value of annuity table. So I've tried to connect these by color. So this green question will apply to this green table. This purple question will be purple, orange, orange, blue, blue, so on and so forth. Okay? So when it comes to the time value money, it's real important to know what your money is going to be worth down the road, what it's going to be worth today. Do you remember when people have won the lottery, they sometimes have the option of taking a lump sum, or they can get payments for X amount of years? So something like future value, present value can help them make that decision. Also, you might be wondering, between two investment proposals, if you were to go with proposal A versus proposal B, and the times are at different times during the potential. In other words, if something is in a 5-year plane and another thing is on an 8-year premise, how do you know which one is the better decision? Well, if you can bring both decisions to the present, or you bring both decisions to the future, doesn't matter which one, you'll be able to make the right decision. Now, having said all that, sometimes even though the paper says to do A, you might opt to do B because of the, conditions that are going on right now in your financial life. So you might say, well, I know it's better to do B, but I need the money right now, so I'm going to stick with A, even though A is not the better choice on paper. Okay, so that's just something to think about. So this is chapter 9 of your textbook. Feel free to read it through. I hope you do. But I'm not going through actual examples out of the book like I did last time. I just kind of picked these off the top of my head, and we'll do these. And when you go back and read the chapter, you'll have a better idea of what you're reading. Okay, so number 1 in green, it says we invest $5,000 today at 6% interest rate for 5 years. So if you invested $5,000 today, went to the bank and you put $5,000 in there, and they guaranteed you 6% every year for 5 years, how much would you have in the bank at the end of those 5 years? So that would be nice to know, right? Because if, that may impact whether or not you decide to invest. You might say, it's not worth it. I'd rather go put the money somewhere else that they're giving me a lower rate, but they're locking it in for more years. Who knows? So this was a common thing maybe 20, 30 years ago, 45 years ago, 50 years ago. People used to get CDs, certificates of deposit, where they would lock their money in at a higher interest rate than a typical savings account. And they still have them today, but you just don't see too many people using them and using banks as much, because what do you get from a savings account these days? 1% if you're lucky. Before we're done here, I'll go through a little example of how long it would take you to double your money, which is crazy, right, when you hear about it. So anyways, so let's go ahead and do this first example here. Again, I said $5,000 invested today. So what are we trying to figure out? Are we trying to figure out today's? No, we already know today's value. It's 5,000. The question says calculate future value. So if you look at those tables that you printed, I gave you the future value table A1, and then future value table of annuity A2. So they kind of look like this. I don't know if I probably can't see it too well, but hopefully you have the handout. And then there's two more tables, A3 and A4. Present value of a single amount, and then present value of an annuity. So there's 4 tables that you gotta know how to use. So when you're looking up these tables, it's very easy to work with. And again, I don't know if you can see this first one that I have here, but as long as you can find where the two numbers intersect, then basically you have your answer. So for example, in this particular case, I said we're investing $5,000 today at 6% interest rate for 5 years. So go across the top until you find the percents. So you're going to find 6%. So it's 1%, 2, 3, 4, 5, 6. So go to the 6% column and go down to the 5th period. And where those two numbers intersect, you should see what I have here in green, 1.3382. Okay? And all you got to do is take that 1.3382 and multiply it by $5,000, and voila, you have your answer. So let's do that. So if we take $5,000 and you multiply that by that future value factor, it's actually referred to as a factor, this 1.3382. And let's do that multiplication. And that's your answer, except we don't need all those zeros. Whoops, I'm going the wrong way. To the nearest dollar is fine. So I get 66.91, and this came from table A1. The future value of a single amount. So 6% for 5 years. So that's, 6% at, well, let's do 6%, comma, 5 years. And you get that 1.3382. Okay? That's all there is to it. So if you want to find a future value, you've got to know how many years in the future, and you got to know what is the interest rate that's going to be applied in every year, right? Number 2, we invest $5,000 annually for 8 years at 9% interest rate. Calculate the future value. Well, notice the difference between 1 and 2. In number 2, it's $5,000 annually. So every year for 8 years, we're plopping $5,000 into the account. So 5 times 8, there's at least $40,000, right, that we're putting in. So what's this 40,000 but 5 at a time for 8 years going to be worth 8 years from now? So again, we're going to start off with the $5,000. And we're going to be multiplying that by a factor. And that factor, these symbols are killing me here real quick. I got to put them in the center position. So that factor, so notice the purple here, we have to go to table number 2, table A2. And in table A2, this is when you want to calculate future values for a repeating event. So again, you go across until you find 9%, and then you go down to 8 periods, and you should see the number that I have here highlighted, 11.028. Now, you know the answer is going to be at least 40 grand because you're putting in 5,000 every year for 8 years. So 5 times 8 is 40,000. So if you get anything less than 40, you've made a mistake on your calculator, okay? Or you've looked up the wrong number in the chart. So, but notice this number. Look at the numbers that are in the green table, all right? They're all like 1 point. All right, they're just 1 point, so they're pretty small. But look at these annuity table ones. 1, 2, 3, 4, 5. All right, so we're talking about repeating events, or your interest is earning interest. So if I take 5,000 and I multiply it by that 11.028, notice I get 55,140. I know I've put in 40,000 of my own money, so the answer better be higher than 40. And at this, interest rate, 9% for 8 years That's going to give me $55,140 in my account after 8 years. Okay. Let's go to scenario 3. What if someone gives us $7,000 3 years from now? So they said, hey, when you graduate, let's say you're a sophomore, right? And they say, if you, like it's your grandfather, at the end of the year, when you graduate, I'm going to give you $7,000, right? What's that $7,000 worth today? Okay. So that's what we're trying to figure out, because what if your grandfather said, I'll give you $5,000 today to go to college, or I'll give you $7,000 3 years from now when you graduate? Which one would you take? You know, if you have no money whatsoever, you're probably going to take the 5. But if you can function and knowing that you're going to have an extra $2,000 at the end of these 3 years, would you be willing to take the more money? But you got to wait 3 years to get it. So what's better, $5,000 today or $7,000 3 years from now? So that's what I was talking about before when I said, hey, let's compare investment scenarios. So this $7,000 is a one-time event 3 years from now. So and we're going to be calculating the present value. I figure out what the $7,000 is worth today. So I'm going to be using table A3. And in table A3, I'm going to take this $7,000 and I'm going to be multiplying it my ADD is kicking in here. So we're going to take this 7,000 and we're going to be multiplying it by whatever 3 periods at 5% is. So look at table A3, go to the 5% column, go down to period 3, which is this 0.8638 number that I have highlighted. And then let's multiply them together. So 7,000 multiplied by 0.8638, and the answer we get, $6,046.60. If you said $6,047, that's fine. So that's what it's worth today. So let's go back to that question that I posed. If your grandfather said, I'll give you $5,000 today, or $7,000 3 years from now. Well, $7,000 3 years from now, today is worth $6,046. So the $6,046 is greater than the $5,000 that your grandfather would give you now. The better decision is to wait and get the $7,000 3 years from now. But you might be saying, well, I'm broke. I'm homeless. I'm living on the street. I need the money now. Well, okay. Then you ignore the present value, future value stuff, and you just go based on actual needs. But in reality, if this was a decision like by a business, again, you know, they could be desperate for cash flow, so they could opt to ignore the advantage of waiting. But if you can wait, you're better off waiting. Okay? And then scenario number 4, someone gives you $2,000 a year for the next 14 years. So let's say this is your grandma, all right? Your grandma's like, your grandfather, he's got money. But I'm going to give you $2,000 a year for the next 14 years. And let's say the interest rate is 4%. So I've got the annuity table. So this is now table A4. And with table A4, it's trying to find the value as of today for a repeating event. So we're going to take the $2,000 and we're going to multiply that by 4%, 14 periods. So again, go to the 4th chart and look up 4%, 14 periods. So wherever they intersect, and that's going to be the present value of annuity factor, 10.563. And do that multiplication and you get 21,126. So again, think about it. 2,000 times 14, that's 28. That's 28,000. So what's 28,000 over the course of 14 years worth today? 21,126. So let's say, your grandmother says, I'll give you $5,000 today, but, if you wait for 14 years, you'll get $2,000 every year, and that's a total of 28,000, but today it's worth 21. So 21 is way better than 5. But again, you might say, I need the money. All right. All right, those are the 4 tables. So just for the heck of it, I threw a question number 5 at you. Someone will give you 28,000 14 years from now. Assuming a 4% interest rate, calculate present value. So which table are you going to look at? Okay, are you going to look at A1, A2, A3, or A4? Well, remember, 2 of the tables calculate future value, 2 of the tables calculate present value. So the question says calculate present value. So that eliminates A1 and A2. So you're looking between A3 and A4. Well, this question I just asked looks very similar to number 4. You're getting 28,000 14 years from now at 4% interest. The difference is in number 4, you were getting an annuity. Every year you were getting an amount. This one, it's a one-time thing. So you're going to be using basically not the annuity table, but for just a regular present value table. So let me get rid of the word annuity. Okay, so regular present values. So you're going to look up the number 28,000. And you're going to be multiplying that by 4% and where 14 intersect. And you're going to get 0.5775. Do that multiplication. And look at the difference in answers. I mean, both cases, you were getting 28,000. 2,000 over 4 years, 14 years, 2,000 times 14, 28,000. And here you're also getting 28,000. But because you're getting 28,000 at the end, right now it's worth 16. Whereas if you were getting 2,000 every year for 14 years, it's actually worth 21. That's because your interest is earning interest along with the original amount. So basically, that's huge. When your interest can earn interest, that's like basically free money. Okay? So that's how you use basically the present value and future value tables. So your textbook uses a variety of examples as well, but this is all I'm expecting you to know in terms of how to use the table. Okay, but let's say you don't happen to have a table in your back pocket every time you're out and about and you're trying to figure out, geez, wonder what my mortgage payments are going to be, or I wonder how much I'm going to have to pay back the bank and all this when I buy a house, stuff like that. So some of us, I know pretty much all of us, almost all of us, have a smartphone of some sort, unless you still have a flip phone, but I guess that's a possibility. But most of you, I would imagine, have a smartphone, and you could actually download an app that would replace these tables. So let me scroll down a little bit. If you do download the app, which app do you download? Well, if you typed in, in the search in your apps store, and you typed in financial calculator, you're going to get a slew of ones. Some that are free, some temporary, some that you have to pay for. I think that the one that I have cost me $3, one-time payment, but I don't have to worry about it expiring on me. But mine is actually called Financial Calculator, okay? And the icon, where's my phone? I don't know if you can see this, but my icon right over here, it's like a blue circle with a calculator on it. That's the app that I downloaded, okay? That's me and my girlfriend, but so that's the app. And then when you open it up, you get something that looks like this. and I kind of copied it over to the right on the screen. Okay. There were some things I couldn't put in arrows and things like that, or check marks, even though I could have gone into WYSIWYG or Wingding, excuse me, and put them in as symbols, but I didn't feel like it. All right. But if you notice in this financial calculator, there are some important buttons that I have highlighted in yellow. One is the compute button, and then the other ones are this N, I, Y, PV, payment, and FV. PV stands for present value. FV stands for future value. IY is your interest for the year. And N is number of years, number of periods. Okay, so all the buttons are great. Obviously, you got to enter amounts, so that's what the green numbers are for, your typical numbers. There's also a positive / negative, so you can turn a negative into a positive and vice versa. But the keys are the ones that are in yellow. Okay, compute. Then that CPT stands for compute. Then we got N, IY, PV, payment, and future value. So instead of using the tables, we can use this approach. So I have here examples using smartphone calculator app. The trick to use the interest rate as a number, not as a percent. So I know it says 6%, but don't type in 6%. You're going to just put in 6. If it was 6.5%, 6.5. Okay. So the way you're going to do it is as follows. So if you have the app, sweet. If you want to download it, go ahead and download it. I'll wait a minute, and then, you can pause me right now, and then I'll wait for you to download it. It's really cool. I think you'll love it. You'll find what we just did using the tables 10 times easier by doing it this way. So why don't you pause me right now, and then I'll come back and finish it. Okay, so hopefully you're back. All right, so to do this, what we're going to do is we're going to follow this procedure. We're going to put in the number 5 for 5 years. So I'm going to imagine I'm typing into our little calculator. I'm going to hit 5, and then I'm going to type in 5, and then I'm going to type in the N. So hang on a second. I want to center all of this. I should have done that ahead of time. I wasn't thinking. Okay. So you're going to put in 5N. So press 5 on your financial calculator and then press N. Then we're going to press the number 6 for interest. And then we're going to type in the IY button. Not type it in, but press. So literally, you're doing 5N, press 5, press N. Press 6, press IY. Then we're going to type in the number 5,000. And you're going to enter that as our PV value. That's our present value. And then this is really, really important. This is where people screw up. You either have, remember how we had 4 tables? 2 for present value, 2 for future. But of the 2 that we have, one was for a single amount and the other one was for a repeating. If you have a single amount, you use PV or FV, depending on what you're solving for. If you have an annuity, then you have to use payment. Payment means annual payments. So we don't have any annual payments, but I have to tell the calculator that we are not dealing with an annuity. So I have to enter 0, no annuity, basically. Okay, and then what I'm going to do then is hit compute, CPT, and then what am I trying to figure out? Future value. So let's start from scratch. You do 5N, 6IY, 5,000 PV, 0 payment, compute FV. So in yellow, I have the keys that are on the financial calculator. In green, the numbers that you press as far as numbers. The little black ones, we don't do anything in front of that. So it's just compute FV. So if you do it, you will get the answer. On your screen, you probably would get a negative value. And the reason why you're getting it, and basically notice right here, ignore negative sign in your answers. So pretend the negative sign is not there. You get 6,691.1279, which translates into 6692. Okay, and that's your answer for the first one. Now, I used the same data when we used the table. So we got 6692 here. We got 6691 using the tables. Your calculator app is more accurate than the tables because the tables only go to 4 decimal places, whereas your app takes the number to infinity. So your app is going to give you a more accurate answer, but the table was within $1, which isn't bad at all. Okay, so again, 5N, 6IY, 5000 PV, 0 payment, and then compute FV. So literally just enter as you see me doing this horizontally. So there are 10 actions on your part. 5N, 6IY, 5000 PV, 0 payment, compute FV. 10 moves. Okay. Let's put that over here. 10 calculator moves. Every time. Okay, so let's do the next one. We invest $5,000 annually for 8 years at 9% interest rate. Again, calculate future value. Well, I know when I get to the end, I'm going to have to compute future value. So that I know, all right, at the end. But let's go through the steps. So what do I have here? I want to do the N first. So number of years, so 8N. What's my interest rate? 9. So click 9 or type in 9 and then IY. IY with my little I. Sorry, you know I had to say something stupid and silly. So again, 5,000. Okay, but is the 5,000 a one-time event like it was in number 1, or is it an annual event? It's an annual event, so we're going to put 5,000 for payment. So this time we put 0 for PV. So we're saying this is not a one-time event. This is a repeating event. And then compute FV. So really the only thing that switched was right here. All right, we put 5,000 as PV. This time we put 5,000 as the payment because we're making payments. So last time there were no payments, so we said 0 for payments. Last time we had a one-time event for PV. This time it's not a one-time event. So if you go through the math, 8N, 9IY, 5,000 payment, 0 PV, compute future value, 10 moves, you should have come up with 55,142.3690. Oops. That's what I got on my screen, but you probably have negative in there. Ignore the negative, like I said before, right? If you wanted to avoid the negative answer, instead of putting 5,000 as a positive, you would put 5,000 as a negative. So don't bother. Why go through all that hassle? Just ignore the answer that says it's a negative answer. Just make it positive. So that's 55,142 as our final answer, rounding to the nearest dollar. So let's compare that answer to the answer we got in number 2 up above. Remember 55,142, we had 55,140, so we were off by $2 using the tables. On the test, I don't care which one you use, app or tables, just let me know. Used app, used table, so that I know which answer to look at. Okay? Let's do scenario 3. Someone gives you $7,000 3 years from now, assuming a 5% interest rate. Calculate present value. I'm going to shut up for a second and let you play with your calculator here for a second and see if you can figure out what the answer might be. Okay. So if you, I'll do it with you here. So someone's going to give us 7,000 3 years from now. So we're going to be computing, when it's all said and done, we will be computing present value. We know that at the end. So what are the number of periods? So it looks like we've got 3 periods, right? And so that would be 3n. The interest rate is 5%, so we're going to type in 5 for IY. They're giving us $7,000 3 years from now, not $7,000 every year, $7,000 one time. So that is our future value figure. And since this is not a repeating event, our payment is 0. So let's see how it goes. So we got 3n, then we've got 5 IY, 7,000 future value, 0 for payment, and we're going to compute present value. And I get negative $6,046.8632. Hopefully you got the same thing. So I'm going to ignore the negative sign like I told you guys to ignore it. So 6,046.8632. Which rounds up to $6,047. What did we get up top? $6,046.60. And this time we got $6,046.86. So we're pretty close. So notice this was only 3 years. So the disparity between the table and the app is going to be very small. The more years that are involved, the greater the disparity in answers. Okay. Let's try the fourth one. Someone will give you $2,000 a year for 14 years at 4% interest rate. Calculate present value. So I know my last 2 buttons I'm pressing are going to be compute PV. That's weird. There it is. Okay. And we're going to have a payment situation this time. and this time the future value will be 0 because we're given the future value. All right, so let's go ahead and do this. Someone will give us $2,000 a year for 14 years at 4% interest rate. So let's put 14N. What's the interest rate? The interest rate is 4%. So 4 IY. This is a $2,000 annual payment. Since it's not a one-time event, we're going to put 0 in for the future value. So if we do that math, 14N, 4IY, 2,000 payment, 0 for future value, compute present value, I get $21,126.2459 on the calculator, which rounds to 21,126. So let's look at the answer we got from number 4 earlier. 21,126. And pretty much the same thing. So this one kind of goes against what I said before about the more years involved, the more the disparity. I guess it's more random than I thought. Okay, last question. You guys try this one on your own. Number 5, someone will give you $28,000 14 years from now and assume that 4% interest rate. Calculate present value. Give you 20 seconds before I start chiming in. Okay, so you should have, if I didn't give you enough time, pause the recording, keep working on it. In the meantime, what you should have done was, how many periods did we have? 14. 14N. We have an interest rate of 4%. Now this is a one-time event, so we're putting in 28,000 as the future value. Someone's going to give us 28,000 sometime in the future. So there's no annual payments, so 0 for payment. And then compute your present value. And if you did it right, you should have come up with 16,169.3023. That's what I got. Round that to about 16,169. Let's compare that to the answer we got up top, 16,170. So off by $1 compared to our previous results. Okay, so now you know how to use tables to calculate future value and present value. You also now know how to use your app. Okay, there's another way you can do it, and that is just using Excel, like I'm using right here. So Excel was like, before there were apps, you could do this stuff using formulas on Excel. Remember, like equal sum or equal this cell plus that cell? Well, I have put in here the formulas that you would use. Now that may seem a little complicated, but once you start entering the formulas in Excel, it becomes more understandable. So for example, let's say I do this equal. So you know in Excel, as soon as you type an equal sign, you're automatically going into that math realm of Excel or copying something. So if we want to do equals sum, it'll start asking you, what do you want to add? But I'm going to do equals FV. And look what happens when look what it says, returns the future value of an investment based on periodic constant payments and a constant interest rate. But as soon as I put in a parenthesis, now it tells me exactly what it wants. It wants the rate. It wants the N per number of periods. It wants payment and it wants PV. That thing about type, you ignore. All right. So take a look at what I have above number 1. Examples using Microsoft Excel. The trick is to use interest rate as a decimal, not as a percent. If you put it in as a percent, you're gonna throw your answer into another stratosphere, right? So let's put in what we know. This time it wants the rate first and number of periods second. The app wanted the number of periods and then the rate. I think you could have done it in either sequence on the app, honestly. But let's say the rate is 6%, so we're going to put in 0.06, comma. So you physically got to put in the comma. Number of periods, 5, comma. Is this an annuity situation? Is this a repeating payment situation? Nope. Nowhere in there does it say annually. It's a $5,000 investment, one-time event. So the payment is 0. Remember on the app you had to put 0 payment? Here, just 0. And then we're calculating the present value, and that is $5,000. I'm going to put it in as negative. It's easier on Excel to put in the negative sign. It might be a little harder on the calculator. And then I'm going to close the parentheses. So take a picture of that if you want. That's 6% is the rate. 5 is the number of periods. This is a non-payment scenario, and the present value is negative 5,000. Okay, so if I hit enter, look at the answer I get. 6691.13. Let's compare it to the app answer. 6692 compared to the table, 6691. All right, let's try number 2. We invest $5,000 annually for 8 years at 9% interest rate. Calculate the future value. So equals FV, open parentheses. That's the starting point. You need to have those 3 pieces of the puzzle. Rate, 9%, 0.09, comma. Number of periods, 8, comma. We do have a payment. It's $5,000. Let me put it in as a negative. This way my answer comes out positive. I don't have to. I could have put it as a positive. My answer would have been negative and just ignore the fact that the result was negative. And this time my PV is 0. It's not a one-time event. So I got to tell Excel it's either a payment situation or a one-time event. Close the parenthesis, and I get 55,142.37. So if after I upload this into Blackboard, if you wanted to, you could literally click on this cell and then look up here. It tells you exactly what I wrote. All right, if you click on the 6691, you can see my every move. All right. So now we're calculating present value. Right? So I need to change this to PV, and I need to change this to FV. Okay. So now, instead of starting with equals FV, I'm going to start with equals PV, open the parentheses. So look what it wants. It wants the rate, which is 5%. So 0.05, comma, number of periods, 3. It says someone will give you 7,003 years from now. So n per is 3. This is no payments, so 0. And the future value is 7 grand. I'll put it in as a negative. And that's it. Close the parentheses. And you get 6,046.86. Let's compare it to the other answers. 6,004. Actually, look at the app. 6,046.86. So pretty much the app in Excel will give you the exact answers because they take, the numbers to infinity and beyond. All right. Number 4. Someone will give you $2,000 a year for 14 years at 4% interest rate. Calculate present value. Okay. So equals PV open parentheses. You got to remember those first 3 steps. Because if you don't, you get that. If you just do the equal, you just get that. PV, not good enough. You got to open the parenthesis. So the rate, 0.04. Number of periods, 14. Is this a payment situation? Yes. So it wants the payment info. We'll put it in as a negative, negative 2,000. And future value, 0. Close the parentheses. One of these always has to be 0. It's either payment is 0 or F fee is 0. If you're dealing with present value, either PV is 0 or payment is 0. You have to have a 0 in all of these. And notice we get 21,126.25. 21,126. Remember the app gave us 0.2459. I could make this go out that far as well. Look. There it is. You get the same answers on the app as you do with Excel. Identical. Depends on how you have your Excel to how many decimal places. Okay, last one. Someone will give you $28,000 14 years from now. Assume a 4% interest rate. Calculate present value. So pause my recording right now. You figure it out. And then I'll resume in a second. Okay, so if you did it right, you're going to go equals PV. Open the parentheses, the rate, 0.04, comma, number of periods, 14, comma. This is a one-time event, so therefore you're going to put a 0 in for payment. And then I'll put in the 28,000 as a negative, close the parentheses, enter 16,169.30. 16,169.30, and we used the app. Okay, so hopefully you're finding this to be very easy. You may need to listen to it one more time, and then I'm sure it'll click, or read the chapter and you'll see some of the examples. The next thing I want to talk about here and wrapping things up is the rule of 72. And the rule of 72 is how long does it take to double your money. That's the rule of 72. So if I had a 6% interest rate, okay, so let's assume a 6% interest rate. What I would do is I would take the number 72, actually I'll show it here, 72 and I would divide it by that 6%. So equals 72 divided by 6, and it says 12. So it would, if you have an investment and you're getting 6%, so you put money in and you know you're going to get 6% interest, it's going to take 12 years to double your money. That's the rule of 72. Somewhere in that 12th year, your money will double. Okay? What if you wanted to find the appropriate interest rate? Right? So what if, assume a 5-year loan, calculate the interest rate in order to double your money. So if you take the number 72 and you divide it by 5 years in this case, (72 divided by 5), 14.4% interest. So if you want to double your money in 5 years, you need at least a 14.4% return on your money. Pretty cool, huh? That's the rule of 72. Okay, that does it for today. For homework, what I would like you to try, get the book here. So homework, this is on page 340. And 341. Please do questions 1 through 5. Whoops, that doesn't help. So quick comment, because I'm looking in question number 2 and it says semi-annual and quarterly. So let me go back up here real quick to the first thing we learned. So if you had something where you had to do something semi-annually, right? So let's say this one here, 14 years, 4%. If you were calculating this semi-annually, you would double the periods and cut the interest rate in half. So if semi-annual, you would double the periods and cut interest rate in half. So in this case, you would be looking up 28 periods, 2%. So 2% at 28 periods. That's what you'd have to look up in the table. You wouldn't look up, go 4% down 14. You'd go 2% down 28, because if you're getting interest semi-annually, that's twice a year. So every year you're getting double the interest. So you're getting paid interest 28 times, but it's every 6 months. So half of 4% is 2%. Okay? And then you can figure out what it is quarterly. I'll upload the solutions to all of the questions, but that's what you should know how to do. So when it comes time to doing questions on the exam, If you choose to, well, hopefully you'll have to do at least one of these. You'll have to do something from this chapter, but you will be able to choose whether you use the tables that I uploaded in Blackboard. You can use an app if you downloaded that, or you can use Excel. That's up to you. I'm only asking you one favor. Whichever technique you use, just write that at the top of the problem. I used the app. I used Excel. I used the tables. And then, I know what to look for in terms of answers. Okay? All right. That's it for today. And hopefully I'll be getting everybody's tests by tonight. Again, your project is due May 4th. So hopefully I'll get that in. Your test will be due May 4th. So we're going to look to try and have everything that you owe me, which is this last test and the project, aim for May 4th as your due date for everything. Okay? All right, guys. We'll see you next week. Next week, we'll be working on Chapter 14. All right. Bye-bye. Be safe. Be healthy.